Welcome back to the next session. So post-lunch is usually a little boring, but what we thought is to make it a little more lively by having a panel discussion. We have excellent speakers whom you have heard all this morning, and there are a few which are lined up in the afternoon session as well. So let me introduce you to the panelists. So may I now invite Dr. Anita Krishnan, our first panelist, to the dais, please. Dr. Anita Krishnan. Okay. Professor Annapurni Subramaniam. Professor Hemalatha Balaram. And Professor Rama Govindarajan. So we have 4 panelists. In India, Kal, Aaj aur Kal, very nicely coined by Susheela. So let me introduce you the panel moderator, Dr. Susheela.
Good afternoon and welcome back to the afternoon session. This is an absolutely brilliant panel, and you've heard 2 of our leading women scientists who are on the panel this morning. You've heard them. And you're going to hear the other 2 in a short while. But thank you all for agreeing to be on this panel. And we just thought we would explore a few issues a little more deeply, and do it informally and talk about a number of different topics. So that's why this panel. Now, so I'm going to start by asking you, what started your journey into STEM? What has your journey been like? And why have you chosen the topics that you chose? Rama, for example, you started life as a chemical engineer, but you're not really doing pure play chemical engineering. So what is it that took your career, and what was it that you kind of did? So maybe I'll start with you, Rama.
Yeah, so in fact, I would have liked to do maths, Susheela. From the time I was young, I liked maths. It was my favorite subject. But I went into engineering basically because it earns you a living, or in those days it was assumed that you can do better with engineering than with maths. And so I went into that, and the rest of it I would say was a random walk. But the basic thing that I got from chemical engineering was fluid mechanics. And using fluid mechanics, I went into a PhD in aerospace. And so I learned fluid mechanics from completely two different perspectives, and that took me into asking questions about Earth.
Professor Hemalatha?
What got me into science and research? Well, I would say it goes back to my high school. We had 2 good teachers in science. I opted for science, though I did like literature very much. But then everybody was going into science. I was doing well in class. So I opted for science. And we had 2 good teachers, one in math and other was in chemistry. Of the 2, I liked chemistry very much. And subsequently, I went on to study chemistry in college. And while doing my master's at the University of Hyderabad, we had Professor D. Subramaniam, who writes in Hindu periodically, who taught us what you would now call chemical biology. And that's when I switched from doing pure chemistry to looking at chemical biology. And the course that we had in master's was excellent, actually, with a lot of research component put into it at the University of Hyderabad. And I never looked back, actually, and went into research as a career.
For me, I think it was a very random journey. It was nothing planned. I always, in school, as Dr. Hema also said, I did well in science, and we used to have a science club. And in the science club, when you enter the labs, you get to wear a white coat, not normally. So this was a big motivation for me that when I grow up, I will work in a science lab with a white coat, It was as simple as that.
And you do now.
I do it now, yes. So I mean, I had a very unconventional way of, running through career. Today morning you asked me, I am intrigued by your Ladakh journey. So I married an Air Force officer who moved around multiple places, and most of them remote places, not many opportunities. So I spent some time teaching science, what I learned. And then I came back to mainstream science, cleared my CSR exam, got into PhD. So overall, it's been a journey which I've navigated with whatever life threw at me. It was never a planned journey for me, but I enjoy the science I do in every tenure.
Yeah, for me, science was not on the plate for me when I was growing up because it was music. My parents were musicians and all the time it was music at home. Either it would be teaching or concert or some discussion. Even my mom will be teaching and I'll sit next to her and I take down notations of what she's singing. Because impromptu singing, you have to take down notations. So I would learn to do how the notations are done and I would do that. But I always liked mathematics, and there used to be some quiz or some, not quiz, basically puzzles. There would be some Kanaka puzzles will be there and someone will say, okay, can you solve it? So I used always like to solve it. I don't know the techniques, but I'll somehow manage to solve that. So people used to say, oh, you can do it, you can do it good. So I used to get kicked up by saying that, okay, I can do that. But other than that, there was no major support. My parents had no clue what I was doing. But I used to tell my father that he used to teach a lot at home. My mom used to be teaching most in college. But I used to say that give me some few hours in the evening for me to study, because when the music is going on, I always am soaking up music. I can't focus on my study. So I said, no, please stop it by 6. So after that, I can study. So I used to get up in the morning also study, because early morning there won't be anybody teaching. So I can finish my studies before they start doing music. But I also have to practice because that's part of the routine we have it at home. But I used to look up at the night sky there, and it used to be very beautiful. And we used to have power cuts when in summer, and no way you can sit inside the house. You go out and start looking at the stars. So I started looking at them, and they also used to look at the Milky Way early in the morning. So I used to be intrigued, and I wanted to do something, but don't know what to do, because information was not available then. But so I got an opportunity later, so I thought that is where I have to hold on to, otherwise that will go. I don't know, that's the only one which came in front of me. So I took it, and rest was a happy journey. Yeah.
Thank you. So you can see everyone's had a different journey, but one thing that comes out from everybody is opportunities come to us every day from different directions. How do we take them and how do we move on from there? So thank you all very much for that sharing. Rama, I wanted to ask you, with all the new technology that's coming in, you talked about science as being entertaining. Like some of the work that you do, you called it entertaining. I thought that was beautiful. But what are the new questions that you can sort of now address because of the way science has evolved and the tools that you have evolved?
So I would say, the two tools that are very important for theorists are obviously AI/ML and obviously quantum computing, if it happens. So I think all of us are waiting with bated breath for actual quantum computers to be on the market, and that will be like a quantum jump in the way we do science, the way we do fluid mech, not only in fluid mech, but in any area like health or these things. It's going to be the big tools. And so we're able to solve things we never could imagine solving just because of the size of the computer or the way in which we can abstract things the way ML does. So these are two things. And in experiment, there's incredibly fast cameras, incredibly better ways of looking at things. So in fact, if somebody has a really fast camera, I would even say drop a drop of milk into water and see that thing. You'll never imagine what happens on the very small time scale which you cannot see.
In biology, most of you all know there have been big strides that have been made in terms of genetically manipulating organisms. When I started my PhD, even polymerase chain reaction, the PCR, which was used for COVID testing, was not there. Then you have technologies which have come up. Every protein structure was looked at by X-ray crystallography. Then came this new technique called cryo-EM, which originally appeared, you can only look up to a particular resolution and not beyond that. But now you can really go down deep in resolution and get very accurate information of biological large macromolecules. You have CRISPR, which has come in, and we all use it now to manipulate the genome of any organism that we are studying in the laboratory. You have super resolution microscopes which beat the Abbe diffraction limit. And you have AI/ML techniques which has led to AlphaFold, where you can predict structures using experimentally available data sets. So biology is now at a stage where you have different disciplines contributing enormously. So if you're young students, I would say that just don't focus on biology. You have to have a depth of understanding of physics, chemistry, and mathematics, because biology is something that is changing enormously, both basic biology and health science sector, so that students should focus on all aspects of science and mathematics and engineering to be able to make inroads or make discoveries in biology.
Thank you. That's, I think, a wonderful insight, because what we are seeing, is that there's more and more of interdisciplinary work happening. So, Anita, my question to you is, in the work that you do, how do the other disciplines play in, and what are the other disciplines that play into what you do? And how do you make sure that you're up to date on what is happening?
So I'm a biopharmaceutical scientist, so our business is to make biological drugs. In future, what I think will happen is there will be more focus on automation and continuous processing. Now there are several steps where manual intervention is needed, and that actually comes into the radar when the regulatory agency come in, because compliance, again, if it's manual, it's always, compliance is never 100%. There are errors and things like that. So I see that coming up a lot, which means there's a merging of the product is biological for sure, but the setup is all engineering, as I think Madam also explained very well. Our bioreactors are very, very large scale. It's about 6,000 kiloliters and things like that. So and there is a cellular environment that's happening within that bioreactor, and sampling and sparging of gases, and we are basically maintaining a living, a living broth, right? So there's a lot of engineering that's required, and we have process engineers who take care of it. Although the biologist is the owner of the product, we have process engineers and scale-up engineers who take care of all of this. And moving forward, I think we still do clinical trials for biologics, even if it's a copied version. I'm going to cover that in my talk. We feel that the science has come to a stage where you can predict what will happen in the clinic, especially for a biologic which has already been in human use. If we are able to do that, and if that gets acceptance from regulatory agencies, the biological drugs would be a lot more affordable. It would go down quite a bit, significantly.
So the next question is, what kind of diseases are going to be addressed with biologics?
The ones which the small molecules were not able to address effectively, that's where the birth of biological drugs started. The basic difference between small molecule drugs and biologics is when you inject small molecules, it goes everywhere. It's not specific. Biologics has that clear advantage that they are very specific to the target, and hence the side effects are lower. But having said that, today we are another step ahead. After the invention of the checkpoint inhibitors, we are also looking at the human system already has an immunological complete repertoire of all the cells, as you call, soldiers inside your body. And for some reason, they are deficient in some people. And is it possible for us to repair it and put it back into the patient? That's the cell therapy that we're talking about, which is in a very nascent stage. It would take time to completely switch over to that. And it's never going to be a monotherapy. It's always going to be a combination of therapy, depending on what's the indication, how the patient is, who the patient is, can they be responsive, will they respond, all of these things. So none of it will be completely wiped out, but I think we will move towards more of customized precision medicine, which is what we think.
Annapurni, you said that in your talk you were talking about the fact that the early part of your career was about calibrating telescopic equipment. So can you talk to us about how the tools of the trade are an integral part of astronomy?
Yeah, so as I said, astronomy is an engineering driven, but also it's a tool driven and technique driven science. I think the rest of it is also technique and tool driven. But the technique and the tool also have changed over the time scale. Like when I was student, PhD student, the data is not available like the way you have it in a fingertip. So if I want to look at a part of the sky that night, or let's say some nights are awarded to me in a particular telescope, so I have to go to the telescope and observe that part of the sky for whatever reasons I want, which I have already projected, and that is why the time is given to me. Now, how do I know whether that part of the sky is indeed the telescope is looking at? I need to make sure that it is looking at that part, right? So I need to have some pointers like, okay, you go nearby, you should look at the star, and from here, there's a pattern matching up in the sky you need to do. But to know the pattern matching, you need to have it in your hand, a pattern, what is expected to be seen. Now that you know from the Google Sky or any digitized software, you will get it. But then you don't have it. So only certain libraries used to have negatives of the part of the sky is taken. So those sky print. So it's a science sky survey is done by Balaram, and that negatives are available only in certain observatories. So we had one, and we have to go. The librarian will make sure that it's not photocopied. We can't because it gets destroyed. So we have to take it to a dark room, take a picture of it, and plan. So what I mean is, if I have some nights, I have to plan 1 month ahead of what I want to do. And if I go there and change my plan, I can't do because I don't know where I'm looking at. That was the tool I had to do because it was very inefficient. I have to identify, look at it, is this the one? And then you have to make sure, go to take the telescope and look at it, whether is it actually looking at that direction and giving me the data that I want. So it used to be very inefficient, not only prior, at the telescope also, because you don't know where it is coming. Then you have to take the data, then you copy onto the disk and then bring it here, then actually read through it, and then only one system will be there. You have to queue up to read through it, and then you analyze. So it is a completely inefficient system. But in the 30 years, this completely has changed. So everything is at your fingertips. You can now automate the entire telescope. Evening you see, set up your coordinates and give, and it actually can go identify the object, put it there, give your data. It's completely efficient. So another thing is, like, if the Earth rotates, right? So the sky, you think that the sky is changing. It's basically because the Earth is rotating. Stars rise and set. The telescope engineering system actually tracks. You track on. When you put the track on, it's actually tracking the star. But it's not tracking at the precision level I want. So how do you have to do guiding. So in olden days, what you do is you have to actually, there's a guided telescope will be there along with the main telescope. You have to climb up the ladder, stay there and look through it and guide it. If it's half an exposure, you have to guide it. It will be moving. And the telescope will change. You have to get down, push the ladder, climb up, again do it. Entire night you have to do it in complete pitch darkness. You'll be physically tired by next morning. So if you don't do it, the images will go bad. So now you don't have to do that, because now you have a digital capture, and that image is actually closed loop tracking. If it moves out of that pixel, the algorithm picks it up, pushes the telescope, so that the image goes into the same plane. So huge amount of technological changes happen, huge amount of techniques you do has changed. The software, how you do the data processing is also changed. So I have to learn everything and have to be updated every time. Otherwise, I go irrelevant. Because it's it's rapidly changing. So astronomy, you have to keep learning the new things. Yeah.
And at least you get to have your sleep, and you're sure that after climbing up the ladder, a cloud doesn't cover the
Yeah, so you have to,
telescope.
that's another frustrating thing. It's clouded out, then you have to wait for the cloud to go. Then you wait till that, so it used to be like, tapes and go, to the observatory, spend 2 weeks and come back without any data because everything was clouded. So it used to be very frustrating as well, yeah.
So, yeah. One more, if I can start with you, Hema. One of the, we saw from Annapurni's talk how much of international collaboration, astronomy is all international collaboration now. We saw Rama talking about, the fact that you work with multiple labs. What about the work that you do? How international or interdisciplinary is it now?
I've had, during the course of my entire career, I've had collaborations extensively with people in India and also groups abroad. You have, you can, for biology research, you need lots of money, and you have, Indo-US, Indo-French, numerous groups which fund you. I've also benefited by collaborating with people who do, who are in the physics background, who do molecular dynamics, advanced molecular dynamics simulations, whereas I do the biology. So collaboration is a part of science, and in biology it has become even more so to collaborate, because you may not have an expertise in all the new technologies that are coming up every day. For example, when I started, there was no genome of any organism except very few had been sequenced, few viruses. And then you had explosion of sequences that came out. When Watson first announced that human genome is going to be sequenced, one expected that it would take a very long time. But it happened very short because people realized that you can do what is called shotgun sequencing, where you sequence in small bits and assemble. So for all these technologies, if you do not know, it is best to collaborate, because there's so much to learn. You can't learn all of them. You have a question, one way of answering. So collaboration has been, part of my research program. We've collaborated very extensively with different groups in India and abroad.
Thank you. Anita, if we were to, we talked about open data when Annapurni was presenting. But if in medical science, from the point of view of the work that you do, or more broadly as well, if we had the ability to have open data, because now the technology pieces are all there, but if there was publicly available open data pertaining to health and medicine, what are those things which would be in your wish list? And how can everybody, participate in improving the overall health of the world?
Okay, so again, I'm coming
I know
from...
it's a big question, but...
Yeah, it's a broad question, but I'll take a stab at it. I'm coming from a for-profit organization, okay? So time is also currency in for-profit organizations, so nothing comes free, at least there. But having said that, there is... So I think we had a discussion about what is invention and what is discovery, what is science and what is technology. Technology cannot exist without science. Although people have moved on into technology and the passion for science has gone down largely. Even today we see when we get a new problem, so a lot of things are templatized in our industry, which technologists can easily go through. But whenever you have something which is completely different, that's where the science strikes in, and people who are good in science only have the passion to chase things and solve it. We see that very clearly even in this. But coming back to your question, data belongs to a particular company. It is never made free. It's completely confidential. You will see in my slide, although I picked everything from literature because I can't do it, everywhere it's written privileged and confidential. I think those are the legalities around corporate research. But still, having said that, there is quite a lot of information that's available. When we submit our dossiers to the regulatory agencies, some summary of it is published, and with a lot of black and redacted lines, which are critical information, so that there's patents involved in all of these inventions. So those are preserved. To some extent, I feel, some of these things, beyond patent expiry, at least it should be available. We don't get to see any of them. Although all the reverse engineering is done and dusted by the time they open up their patents, I feel for the good of science, at least at some point, they should open up these things and publish it. Although there are scientific publications, but we know in industry that not everything is published in the scientific publications.
Okay, I think maybe another couple of questions and then we are done. I think one of the big issues that we have is the number of girls and women in science and who are pursuing scientific research. I started life as a physicist, and I always say this very proudly, that once a physicist, always a physicist. But frankly, I'm not doing any physics. Okay, but life, again, just like you, life threw other things at me, and I did other things with myself. But what can we do to bring more girls and women into science? Clearly, today's session was exactly about that. It was about bringing forward and showcasing the work that is being done by women scientists right here in India, in Bangalore. And, so that it inspires a lot of women, girls, and others to take up science. But are there any specific things that we could do? We could start with you, Hema.
As I was telling over lunch, recent PhD interviews in a department that deals with molecular biology and genetics, bulk of the students who come for interviews are girls. In fact, my colleagues say there should be a reservation for the boys because not many are entering biology. There are two reasons independent of gender. This PhD program has become a long drawn-out program, at the end of which, if you want to continue in research and in academics, the job opportunities are very few. We have institutions like ISER starting in no time. They're filled with faculty. Each department has about 30 faculty, and the departments are filled. But the number of students who enter PhD and get PhD either from India or go abroad and get PhD and come back and apply every time we advertise. I was Dean of Faculty Affairs for more than 6 years. For every single advertisement, we would get, very large number of applications. So we have to have an increase in job opportunity. This is independent of gender if they have to apply. With regard to girls, the matter gets a little more complicated because it's such a long drawn-out program. You have to shelve often. Actually, you don't have to do it, but generally felt you have to shelve everything else aside and focus only on your research. I find that many women in science abroad nowadays, especially in biology, those I know, seem to parallelly take both rather than just put off everything. I have to finish my PhD, I have to finish my postdoc, I can't have a family till I finish everything, and then the biological clock is ticking. That becomes too late. So I would say that that perspective should also change, because I can see many abroad who are able to parallelly manage both fairly well. I agree, experimental biology is physically very demanding, but with modern technologies, there are many things that you can take up which you can manage both parallelly. In biology, I find there isn't a dearth of women candidates coming into science. It's only at the senior level they seem to vanish. That is a little difficult to answer as to exactly, why are they dropping out. Some go all the way up to postdoc and are willing to drop out because there is demand. It's not that somebody is pushing them out. There's a demand from the family. Very often, it's only the woman who looks after the child. And even with old people in the house, it's very often that the woman is looking after both her parents and her in-laws. So there is a tendency to say, how many things can I do? I can't handle everything at the same time. So, there's a tendency to drop out. I think with sufficient help at the home level and very good daycare centers, which are actually missing in most places, the quality of daycare centers are not very good. If these improve, I think there'll be more people who will not hesitate to take up an academic career. I'm talking from the perspective of academics, which is fairly demanding. You have to have students, you have to guide, you have to apply for projects, you have also to teach courses. Without projects, much of the experimental work cannot be done. You need extramural funding for all this. So in the context, and to build collaborations within India and within abroad. So this becomes demanding. And I think support systems have to come in place by which more women you will find them in science and in academics.
Thank you. Rama, I think we are running out of time, so I'm going to ask you probably the last question, which is, we said Indian science, kal, aaj or kal. So where do you see research and science and scientific research in the next 2 decades or so? Where do you see things going?
So,
And probably, Anita, you can come in from the industry perspective.
yeah, for me, like the thing that occupies my passion or my worry or whatever you may call it is climate. So like I see not just science but scientists, economists, policy makers, governments, everybody coming together. So I see more and more interdisciplinarity, not just within science, not just intra-science, but also science with other things. And this has to take place very, very soon so that we can answer like the bigger questions and attack them together. So that is one piece that's pretty weak right now, not just in India but everywhere, which should actually come up.
On the industry side, I think I remember it, if I remember it right, Narendra Modi has asked us to become, one of the top manufacturing, highest in manufacturing sector. I don't see it happening very quickly because if you compare China and India, they have huge plants and their diligence and perfection to completion is much higher than the current state of India. Are we not capable? No, we are capable. But somewhere down the line, I feel that diligence is lacking in our culture, which probably is a more recent affair. It is not that we have built temples which are, for generations together, they are standing the test of environment and things like that. Somewhere down the line, I think we have lost that diligence. If we are able to build that, we will be one of the best countries who can pride about our manufacturing capabilities. Today we are very good in research, we are very good in a lot of things. When it comes to manufacturing capabilities, we are not 100% compliant, which is why you see there are so many observations that come in, especially if you want to market your products to the global, in the global side. You need to have that checklist kind of an approach where all of it is met. For example, automobile industry, Japanese, the Germans, they are always on top, right, of everybody else. That's because of their perfection, their error rates in their manufacturing. We are yet not there. If we are able to do that, I think we have a very bright scope in terms of job creation, in terms of skill building, in terms of all of these things.
Thank you very much. I think we've had a very interesting, freewheeling kind of discussion about a number of things. Any final thoughts you would like to add?
No, in my sector, I would say that the next decade or so will be going to be very interesting because the space capabilities are quite, renowned and it's improving, and there will be exciting missions coming up in the sense of Gaganyaan or more missions to moon, etc., and also planetary explorations. But at the ground, also astronomy is poised for a very significant growth because we have the LIGO program which is announced, which is supposed to take off and in Indian soil by 2030. So that's a significant investment in the country. There's also the square kilometer array, which is coming up in together Africa and Australia, but India is a partner. So in the last years, last decade, 3 investments are made: the 30-meter telescope, the LIGO, and the square kilometer array, apart from the space sector. So significant improvement, a lot of projects already planned. So there will be more opportunities, more discoveries, and more HR growth will happen in the country. So exciting times.
Thank you all very much. I hope this last statement, I'm sure it applies for every area of research, and there is a lot of excitement, there are a lot of wonderful questions to explore. We really hope that everyone in this room is going to stay with science and STEM. So thank you again for this, and thanks to our audience. Do we have time for a question? Do we have time for questions? Yeah, you'll be hearing the other speakers as well. Sorry. Thank you.
Thank you, Susheela. It was a very intense discussion, and let's put our hands together again for the panelists for sharing their experiences.